All right, team, we are going to dive into this concept of electronegativity. This is probably one of the most important concepts of this class, especially this first half of this class. That's a foundational concept that is required to understand kind of everything else that we're going to talk about in this term. Okay, so electronegativity. All right, why is this concept so important? This concept is so important because it explains the type of bonds that atoms will make with each other, whether they're going to make a polar covalent bond, a non-polar covalent bond, or an ionic bond. And the type of bonds atoms will make with each other determines how those molecules, once those atoms are bonded, right, they make a molecule. The type of bond that occurs in that molecule influences and determines how those molecules will interact with other molecules, right? And in our cells, we're all just molecules just zooming around, bumping into each other. And so by understanding this foundational property of electronegativity, that tells us a lot about how these molecules are bumping around in our cells are going to interact with each other. Are they going to be attracted to each other? If so, how? Or are they going to repel each other? If so, why? Okay, so electronegativity, big concept that will come back again and again and again. So please watch this video as many times as you need. Find other videos that might be helpful to make sure you are 100% solid, good to go on this concept of electronegativity. So let's jump in. Let's define electronegativity. So electro means electron, right? That's what it's in reference to. And so really electronegativity is how strong of a pull one atom has on electrons when it comes into contact with a second atom. Okay, so how strong of a force it exerts on those electrons of atoms that it might be sharing electrons with, or it might steal an electron from another atom. Okay, so how strongly it holds electrons to itself. So atoms will vary in their electronegativity. Some atoms have a really high electronegativity. So up here, especially in the top right corner, we're kind of ignoring these ones right here, but in the top right hand corner up here, those will have a very high electronegativity. Okay, and electronegativity tends to decrease as we kind of go down and to the left. So these ones over here in group 1, group 2, these tend to have a relatively low electronegativity, and then these ones over here on the top right tend to have a very high electronegativity, right? So these means that these hold on to or pull electrons to themselves very strongly. These ones do not have a tight grip on their electrons. We're going to talk about 3 main types of bonds, all right? Non-polar covalent bond, polar covalent bond, and ionic bond, okay? In nonpolar and polar covalent bonds, electrons are still being shared. It just determines the electronegativity between the two atoms will tell us, are those electrons going to be shared equally? They're going to spend basically 50-50 time between those two atoms, or are those electrons going to be shared unequally, right? Maybe one of those atoms is a little bit greedier, has a higher electronegativity than the other. So this chart right here, okay, I will give you an electronegativity scale, like this one back here. Okay, I will give you a scale like this on an exam. However, I will not give you this chart right here. So we need to remember the difference between electronegativity, what type of bond will form. Okay, we're going to walk through lots of examples in just a minute. So if we have two atoms in which their difference in electronegativity is between 0 and 0.5, so a relatively small difference in electronegativity. When I say difference, I mean subtract one from the other. Take the bigger one, subtract the smaller one from it. If the difference between those two is relatively small, so that means that they are very similar in their electronegativity, they're going to share their electrons equally. Okay, those electrons are going to be basically boop, right between those two atoms. So like right here, these two atoms, so those little black dots are representing nuclei, they're relatively equal in their electronegativity, so the atoms are going to stay basically right between those two. The electrons, sorry, are going to stay right between those two atoms. So they're going to share their electrons equally, which forms what we call a non-polar covalent bond. Non-polar covalent bonds do not have partial charges to them. They are a neutrally charged molecule. So there are no partial charges on a nonpolar covalent bond. So difference in electronegativity is relatively small. We're going to have a nonpolar covalent bond and no partial charges. So for example, if we get chlorine bonded with another chlorine, right? So two atoms of the same type have the exact same electronegativity. Right? Let's go back and look at our electronegativity table. So chlorine right here has electronegativity of 3. So if you have two chlorines bonded to each other, 3 minus 3 is 0. So if the difference in electronegativity is between 0 and 0.5, these electrons, so this orange one comes from this one, this yellow one comes from that one, they're going to be shared equally between those two atoms. So this molecule, has no partial charges. This molecule has no partial charges. All right, but if there is a pretty significant difference between the electronegativity of two atoms, all right, we are going to see that there's two things that can happen, depending on how severe or how significant the difference is between those two electronegativities of those two atoms. So if it's between 0.5 and 1.7, if the difference in electronegativity between the two atoms in that bond is between 0.5 and 1.7, that creates what we call a polar covalent bond. So those electrons they're still being shared, but they're not being shared equally. The electrons will tend to be closer to the atom that has the higher electronegativity. Higher electronegativity pulls those electrons in closer to that stronger atom. And because electrons are negatively charged, right? Remember we covered subatomic particles, electrons are negatively charged. Because this atom that has a higher electronegativity has more electrons near it, it's going to get what we call a partial charge. So that little letter there, that's called a delta. That's a delta negative. That means partial negative. So it's not an ion. It doesn't have a full -1 charge, but it has a partial negative charge. So it is polar. So polar covalent bond results in one atom having a partial negative charge to it in that molecule, and the other atom in that molecule having a partial positive charge to it. Okay? Because this atom over here, this atom has a lower electronegativity, therefore it doesn't have a strong pull on those electrons, and they can get kind of stolen by the atom with more electronegativity. So this atom over here, because it's not getting its fair share of the electrons, remember electrons are negative, a lack of a negative results in a partial positive charge. All right, so again, here's chlorine and here's hydrogen. Okay, so let's go back and let's look at our electronegativity table again. So chlorine has electronegativity of 3, hydrogen has electronegativity of 2.1. So we take 3 minus 2.1, that gives us 0.9, 0.9, yeah? Chlorine has an electronegativity of 3, hydrogen has electronegativity 2.1, 2.3 minus 2.1 gets us in 0.9, so the difference between those two gets us in 0.9, so that puts us in this polar covalent range. So that means when chlorine is bonded with hydrogen, it's still a covalent bond. Okay, those electrons are still being shared, just not being shared equally. So these electrons that are being shared between chlorine and hydrogen, they're actually going to be a little bit closer to chlorine. And again, because electrons, so even though this one is coming from hydrogen, because it has such a weak pull relative to chlorine on those electrons, hydrogen is going to have a slight positive charge, delta positive to it, and chlorine is going to have a slight negative charge, delta negative. And these charges, or lack of charges, are going to be really important for when we talk about how things interact with water, especially. That's next week's stuff, though. Okay, lastly, that last type of bond that we have, yeah, that's an ionic bond, right? And one atom gives up an electron, or one atom takes an electron from another one, okay? So that's when the electronegativity difference between those two atoms, the difference in electronegativity between two atoms is greater than 1.7. If the difference in electronegativity between two atoms is greater than 1.7, one atom, the atom that has a lower electronegativity, will give up its electron to the atom with higher electronegativity, right? So that last image that we saw, this image right here, this is chlorine and this is sodium. So chlorine has electronegativity of 3 and sodium has electronegativity of 0.9, right? So 3 minus 0.9, 3 minus 0.9 gets us to 2.1. So that gets us in this range right here. Okay, so in this range right here, if the difference falls over 1.7, that's going to cause an ionic bond. So that means the atom with lower electronegativity gives up its electron and transfers it, physically transfers it. There's no sharing in ionic bonds. It's going to physically transfer it to the atom with the higher electronegativity. So that forms an ion. When one atom gives up an electron and gives it to another one, that forms a chlorine ion, a -1 chlorine ion, and a +1 sodium ion, right? So we don't have those deltas, so these deltas here, we don't have those deltas with the sodium and chlorine because this is a full charge. One electron moving and creates a full -1 charge and a full +1 charge. Okay, let's go through some more examples. We're going to go through some examples that we're going to see again and again and again. So let's say we have carbon bonded to oxygen. What type of bond will occur? Here's the electronegativity of carbon. Here's the electronegativity of oxygen. So if we take the larger electronegativity, 3.5, subtract the lower electronegativity, 2.5. So 3.5 minus 2.5 gives us 1, yeah? So that means we will see a polar covalent bond. So when carbon and oxygen make a covalent bond, those electrons are not shared equally because of the difference in electronegativity. So it falls in that 1, 3.5 minus 2.5 gives us 1. So it's going to be a polar covalent bond. Which atom's more electronegative and therefore will have a stronger pull on the electrons? Oxygen, right? Oxygen is much stronger than carbon. So if this were oxygen, this would be carbon, oxygen would have the stronger pull and therefore would have a partial negative charge when it's bonded to carbon. The carbon then would have a partial positive charge. Okay, so that means that the bond between carbon and oxygen is a polar covalent bond, which means molecules that have a lot of carbon-oxygen bonds are what we call polar molecules. Okay, so polar bonds tend to form polar molecules. This also explains a lot about water too, right? Oxygen's 3.5, hydrogen's 2.1. Okay, so that also puts us in our polar covalent bond. Oxygen is very, very electronegative. So oxygen will tend to kind of pull any electrons, and most things that it bonds with are going to pull those electrons to itself. So the oxygen has a slight negative charge, and the hydrogens are going to have a slight positive charge in water. Okay, this is what creates a lot of the properties of water, which we're going to tackle next week in week 3. All right, so it's electronegativity. And again, this is a foundational concept for most of what we're going to be talking about for the rest of this term. If you have any questions, if you're confused by this, we're going to go through examples in class, and please come to office hours. I'm always here to help you.